Hello guys, welcome to my YouTube channel. Welcome to the second lecture of Bioprocess Bioreactor Design and Analysis, where we were discussing chemical kinetics and reactor design chapter. Okay, so I discussed constant volume batch reactor equations with you in the last lecture. So I advise you to go and see that lecture because we will be using certain expressions from our previous lecture to derive some more expressions in this chapter. Okay. So the next topic that we have in this chapter is called, okay, so this is the second topic that we have, is analysis of batch reactor data. Okay, analysis of batch reactor data. So for that we have two methods. One is the integral method, okay, and another is the differential method. Okay, so for now on we will proceed with the integral method one. Okay, so let's see what we have in the integral method. Okay, in integral method also we will proceed with the first type of equation, is unimolecular irreversible first order reaction. Okay, unimolecular irreversible first order reaction. Now let's see. So suppose you have a reaction where reactant A is giving rise to products. Okay, reactant A is giving rise to products, and remember this is, we are talking of a first order reaction. Okay, so in that case, if it is a first order reaction, so the rate expression can be given as minus RA. Minus means reactant is getting consumed, that's why, is minus dCA by dt. Alright, and because it is a first order reaction, it's K into the molar concentration of the reactant, that is Ca. Okay, so K is the first order rate constant. Alright, so K is the first order rate constant here, and Ca, as you know, is the concentration of reactant A at time t. Okay, so this is not the initial concentration. So now if we rearrange this, what we can get here is that minus dCA by Ca is equal to K dt. Alright, now we can integrate this from initial concentration Ca0 to final concentration Ca. Okay, and initial concentration Ca0 at time t equal to 0 and final concentration Ca at time t equal to t. So Ca0 at time t equal to 0 and Ca at time t equal to t. We are doing definite integration here. So if we integrate this, we get minus ln. Okay, because you know the integration of dx by x is minus ln Ca by Ca0. Okay. So I'm writing it directly. If we put the limits, we would substitute the values, we will get this one is equal to kt. Okay, so this is one expression. All right, or we can write this here as Ca is equal to Ca0 e to the power of minus kt. This is another result, right? Now this is very important. We will use this in our subsequent derivations. So if you remember the fractional conversion xa or chi a, okay, what did we write it? We wrote it as 1 minus Ca by Ca naught. So this was in our previous lecture, alright. And simultaneously we also showed that dxa is equal to minus of dca by Ca naught. Okay, this we also showed earlier. Keeping these things in mind, okay, we will proceed here from here using this expression. So what we know, dxa is minus of dca by Ca naught. Okay, so this we know, and we know the value of Ca to be, we have got the value of Ca to be Ca naught into e to the power of minus kt. So if we substitute here, what do we get? Okay, if we are substituting here, so we will get minus 1 by Ca naught, I am keeping it outside, d of this whole thing, right, e to the power of minus kt, right. Again, this Ca naught is constant, so we can take it outside. So dxa is minus of 1 by Ca naught into Ca naught into, what is the differentiation of e to the power of minus kt? It's minus of k into e to the power of kt dt, right. So this Ca naught gets cancelled. Sorry, what is happening? And we have k e to the power of kt dt. So this is d of xa. Now what do we know? So from here again, sorry, e to the power of minus kt, yeah. From here again we can write what is e to the power of minus kt. It's actually Ca by Ca naught. Okay, it's actually Ca by Ca naught. So we can write it again over here. So d of xa is k into Ca by Ca naught. Again, if xa is 1 minus Ca by Ca naught, what is only Ca by Ca naught? Sorry. If xa is 1 minus Ca by Ca naught, what is only Ca by Ca naught? It is 1 minus of xa. So we can substitute this over here. It's k 1 minus of xa dt dxa. So we are writing from here. Alright. So this gives you dxa by dt is equal to k 1 minus of xa. So this thing is very important. Now again we can integrate this expression. So let's integrate. So we can bring it over here. 1 minus of xa, it's k dt. We can integrate it from 0 at time t equal to 0 2xa at time t equal to t. So if we integrate this, what do we get? It's minus of ln 1 minus of xa is equal to kt. Now this is very important because you will get a lot of problems, especially batch reactor problems using this expression. Okay, so these expressions are very important. I will mark it for you again. Some expressions. Number one, this expression minus ln ca by ca naught is equal to kt. Number two, ca is equal to ca naught e to the power of minus kt. Number three, xa 1 minus ca by ca naught. Okay. Number four, dxa by dt is equal to k into 1 minus xa. And number five, the final equation, 1 minus ln 1 minus xa is equal to kt. Okay, so this brings us to the end of the first type of first order reaction, unimolecular irreversible first order reaction using the differential method, integral method, sorry. And we will see another type of reaction using the integral method before proceeding to the differential form. We will keep posting more videos on bioreactor design analysis. For more such videos, tune into our channel and please subscribe to continue our preparation. As you know, this channel is not yet monetized. So if you want to support the growth of this channel and to make sure that I keep posting videos, such videos free of cost on the YouTube, you can support my channel by contributing in a generous amount, whatever you like, to this UPI ID. You just have to open a UPI, be it Google Pay or Paytm, whatever. You have to type this UPI ID and send your generous contributions, whatever you feel like. That will help me to support this channel and also to keep posting such videos. It will also motivate me to keep posting such videos and also help in your growth and preparation of a competitive exams. Thank you.